we have 2 points here. One ow. So we have 2 points. So how do you calculate the distance? It's the same. It's 1 minus 0, 1 minus I minus 1, but it's better to write minus 1 plus I. So that's the distance vector. And to calculate the distance, you have to do the same, like this is the same that you do with the normal real vector. I mean a vector with real elements. It means you multiply the first element with the first element, that's okay. Then you multiply the conjugate of the first second element with the original first element, and then you multiply the conjugate of the first element with the of the third element with the original third element. So this is 1 plus 1 plus I, 1 minus I, plus that's minus 1 minus I, and then minus 1 plus I, what does it mean? So it's, it means 1 plus, you know the equation, it's one plus 1 minus I square plus minus Okay. So this is 2, 3, 4, 5. I think so.
So you replaced I with 1? Or here you have I squared.
So here the I square is -1. This is the I square, and this is the by definition.
Okay.
So this is supposed to be a simple task. Actually, you know, I didn't want to give you this Fourier primary component analysis, and there were two bracket miserable, so that there were two two theses that is in the topics, in the syllabus, but when I teach you, then it has no common sense. If you check now the Neptune, at the last day of April, I uploaded the new syllabus. That was one of my duty. It's quite weird. The topics that I don't like and I don't feel I have to teach you, it's tried out. It's not the normal way, but I have nothing to discuss this. Okay. This won't be the most important part of this. Okay. Do you have any other question?
I don't think so.
You are familiar in diagonalization, also with the L decomposition.
Maybe can you repeat the LU decomposition?
Repeat the L decomposition.
Yes.
Okay, great. That's a good move.
Maybe just one of them.
Yes. Great. Let's see. Okay, L decomposition. Okay, let's start with the here. It's better. 11A. That could be a nice example. I checked all stuff. I mean the diagonalization, the equations and everything, and they supposed to be resulted nice numbers, quite nice. Also in the test, because last year, in the second test, the eigenvalue problem resulted in square root something, and it was too difficult, and some of you could not fix it, were disturbed. Actually, not you, but the Hungarians were disturbed, and I feel a bit there. Okay, so what we should do? What we should do is do the Gauss elimination and yes, and that's not so simple, and follow it with matrices. I mean permutation and other matrices, and then put them together, and then we will get the upper triangular and lower triangular form, or echelon form, or what is its name. So the in the purpose of this. That's funny. That's the reason. We have to eliminate all zeros below the main diagonal, and then we know this in a matrix, and that will result one upper triagonal and one lower triagonal matrix. Okay, let's start. So first, I would The first step is to remove the second row, and that would be add the first row to the second row, and that's how. That's it. But this is only for me. Do you have comment? No, okay. So
Would it be a negative?
sorry?
In the identity matrix, would it be a -3/2, not +3?
I think this should be positive. I'm not sure. I haven't finished. Here it's positive, but I don't know. I will check this out right now. Okay? So I do the multiplication right now. It means row. Okay, this is first. Interesting. So this is 2 plus nine. To 0.
Are we trying to eliminate the -3? Making the -3 0, not?
Sorry, what did you say?
We're not changing the first row, we're changing the second row.
Yes.
Yeah.
So something is perfectly wrong, but this. Oh no! No. Professor error. The order of multiplication is not this. the order of multiplication is not that one. So I multiply this with this. So it's opposite. So E1 times A. And then it means 2. And then everything is 0. Here, 6, everything is 0. Then, next row, 3 plus 0, then wait.
Isn't that supposed to be minus 3?
I don't know yet. Just a moment. So which one is supposed to be minus 2? This
Yeah,
here,
that one, yeah.
here. Okay. Yes, it is. But my problem is not that. I'm quite disturbed because usually I don't do this matrix product. Just put the numbers there, and perhaps that's the right way to do it. Okay, but doesn't matter. 2 and 0. Oh no. That's bad. So this is 4, 9, 2, and this is 2, 6, 2. This is 0. This is 1. This is 3. Okay. Let's see if I do this without matrices and everything, then how it looks like. The first and third row is fine. 3 times the first row, that's here, that's okay. Here, that's 9. No, it's okay. It's 9. Okay. And then this 3 plus 0, 3. That's okay. Okay. Sorry. So I do so last time in the class, I did the Gauss elimination and put everything in the matrix directly. And I didn't do the calculation with matrices like right now. That's why it lasts longer. Okay, so the next one is I will not write here. The next one, oh, I must write it. I have no other place. is to add, subtract the twice of the first row from the third row. So the A2 is supposed to be 1, 0, 0, 1, 1, 0. Nothing happens here, but here I need -2, and that's 0, 2. Okay, let's see whether is it good or not. I calculate this, multiply this with this. So this is 2, this 6, this 2. That's fine. Then multiply this and this. That's fine. Multiply this and this. That's fine. Multiply this and this, and that's fine again. Now the stuff is multiplying this and this, means -4 plus 4, and then this, that's -20, then 0 and 9, and then -4 plus 2. I have a very nice matrix, yes, sorry. Zero, that's fine. -3, that's okay. And then -2. Okay. Let's do the same with just -2. Okay. Yes. Yes. Okay. So that was the next. So I have this, and I'm okay with the second row, but I'm not okay with the first row. So I want to add to the second row, to the third row, 3 times the second row. And it looks like one, okay, and then nothing here. Nothing here, but 3 here. I hope so. we will see very soon, because if I multiply this and that, then I got this, this and this. Because so if I multiply this and this, then I got and now the interesting part comes. Multiply this and this, it means 0, that's great. Then I multiply this and this, then it's 0 plus zero. Oh, it's okay, 0, then 1, 3 times 1, that's 3. And minus 3, so that's 0. And then the last, that's this and this, then 2, 0, 2, that's 0. 3 times 3, that's 9. And then no, 3 times 3, okay. And then minus 1, minus 2, minus 2. So this is 2, 6, 2, 0, 1, 3, that's 0, 0, and 7. Okay, so just a moment, here I add the rows 3 times, it's okay, that's okay, that's okay, that's okay. So now we have the following. This is the U matrix, and now we need the L matrix. A matrix multiplied A1, A2, A3 gives U matrix. So I have to multiply this with, what was it? First, yeah. The inverse of this matrix, then the inverse of this matrix, and the inverse of this matrix. And then A is equal to this here I need some help. Okay, so check this out. We are here with this here, and the last row of the task is the same. And why I need help? Because of this. Okay, it should be stop, stop, stop. Oh, there. I did it. Right. High quality equipment and yeah. Here. If you do the multiplication of these matrices that I give you here, then the result will be the so if you do the multiplication, then the result, you can do it matrix multiplication whatever you want, but these are almost empty matrices, actually triangular matrices or operation matrices. So what you can do simply just say the L matrix is what we have. 3, 2 minus 2, and then we had what we had 3, okay, 3, and then 1, 1, 1, 0. So that's the L. You can do the multiplication if you want. You can do the inversion if you want. Doesn't matter. But it's better just copy the elements of E1, 2, 3 matrices, E1, 2, 3 matrices to this L. So that will be the L2. The L2 decomposition. You or me can do quickly is to multiply this. 3 6, 2. This is the LU. 3, 6, 2, that's fine. Then 3 times 0 is 0. No. That's 3. Then 0, 0. That's okay. Then 3. How was this? That's. It's 2, no, it's 3. It's 2. Oh, it's 3. And then 0. But it should be something is missing. The signs. Minus 3, and then everything is 0. That's wait a minute. That's minus 9. Yes, minus 9. And then plus 1. That's minus 8. Then I really like it. It's minus 3 plus 3, that's 0, and 7 times 0, that's 0. Okay? Last track. 2 times 2, that's 4. minus 18, no, it's a 12, minus 3, 9, and then 0, it's 9. And then, times 2, that's 4, then minus 3, minus 5, and then plus 7, that's 2. It works. Okay, which is magic. That is not, which was not described properly, is how you and why you copy the elements of these E1, E2, E3 to this matrix, that's L. You have to copy to the appropriate place and change the sign. Actually, it could be deducted, but I have a bad feeling I didn't explain this properly. You can add this, yeah, I didn't explain this properly. Okay, but yeah. Is it okay? I'm going to give you simple exercises because you will have only 1.5 hours because of the second test. I will have a test with younger and the same day. Once you survive this, I think you will never need to do it again. Okay. Do you have any other question? Okay. Then perhaps we can stop and you can prepare for tomorrow. If you have any other question, okay, tomorrow. You can use anything, that's okay. I also use the notes, so that's why I don't expect you to know everything by heart. You also can use internet. You can use the computation and everything. But if you use that, you have to process it. I mean that if you multiply two matrices or do the L decomposition, then the result is a mess. Sometimes it gives this 0.1666, so this form of fractures. Sometimes the form is something crazy, so I expect everything how we did it, but you can check it. It could you help. So you have to, and then you have to write every steps for calculation. Actually, in the good internet site could give you the steps, but it's not. I don't say it's not proper. It's not so nice. For example, there is a matrix, and the calculation on the internet give you 1 per 7, 1 per 14, and so on. So you do not write this. You normally write 1 per 14 and then the matrix. So when someone uses the other form, then I understand he or she do not understand anything from matrix algebra. Then there is an interesting example, not from here, from my previous job. There was a girl, and the task was to do very simple algorithms, not so simple, there were algorithms. I think she used ChatGPT, that was fine, she did everything, and the algorithms were good. but she missed the last step. To write out the result, the print result on the screen. So I understood she didn't understand the task, and not so much. She passed, but I didn't give her good points. Okay? Okay, then thank you very much, and sorry for being late.
Is it possible that if you give maybe the solution from the exercises so that when we practice we know what's the...
In theory it is possible, in practice not.
Okay.
Because, sorry, but I don't have time for it.
Okay.
Next year I will give, when I will do it again, and you also can use the internet. For every topic, it's still, you can use the internet still. It helps you. Okay? Sorry, it would be, yes, I should give you the results, but I cannot. What I can do is to